Hey guys, and welcome to Special Products of Polynomials. In this video we're going to go over difference of squares, or also known as products of conjugates, and how to square binomials. And we're going to look at a couple formulas that you can either use or not use depending on your personal preference. So the formulas that I'm talking about are up here. So if you have a sum, so binomial sum, and you square it, you could just take the square of the first entry, add it to double the product of both entries, so multiply these guys together and double it, and then add it to the square of the second entry. If you have a binomial and you're subtracting and you're trying to square that, then similar process, square the first entry, multiply the two entries together, double it, but then put a minus sign in the front, square the second entry, put a plus sign, and put that in the back. Now when you're doing the product of conjugates, or a plus minus difference, then all you need to do is square the first entry, boom, square the second entry, boom, put a subtraction in the middle. That's why we like to call it the difference of squares, and you're done. So we're going to look at this both ways. So suppose I didn't know that w plus 4 squared had a kind of formula to run it through. So we would go w plus 4 multiplied by w plus 4, and we go w times w, which would be w squared, then w times 4, which would be 4w, and 4 times w again, and 4 times 4. Combine like terms. If we have a 4w and a 4w, let's combine those together into an 8w and 16. Okay, so there we go. And you can see where this kind of 2ab comes from here, because when we do square a binomial, we're going to get two copies of exactly the same middle term. So that's where we could have just taken 4w and doubled it. That's where it comes from, the formula. So how to use the formula? Okay, well, we have a w plus 4 squared. So w is our first entry, so that's our a. 4 is our second entry, so that's our b. Okay, so the formula says, okay, we'll take a and square it. Okay, so w squared. Then put a plus. Okay, then 2 times a times b. Well, a times b is 4w. Double it. Okay, well then that would be 8w. So it's double it, not square it, which means leave the variable alone, but square your middle term. And then the last thing says, okay, take your b and square it. Okay, so take 4 and square it, so plus 16. So either way, notice you're going to come out with the correct answer. So it's really up to you with what you want to use. So let's look at another example. Alright, so let's complicate things up a bit with fractions, just to show you that we're going to do exactly the same operations, it's just we got to deal with fractions now. So if I do not have a formula or a kind of recipe, let's see, we're squaring this 1/5 x minus 1/7 y. Alright, multiply these guys together. 1/5 x times 1/5 x, 1/25, x times x squared. 1/5 x times 1/7 y, and that's negative 1/7 y. So that'd be minus 1/35, because our denominators are multiplying together. X times y, which is just xy. Okay. Negative 1/7 y times positive 1/5 x. So negative, same thing, 1/7 times 1/5 is 1/35. X times y is x times y. And then negative 1/7 y times negative 1/7 y. Negative times a negative is a positive. 1/7 times 1/7 is 1/49. And y times y is y squared. Alright, let's clean this up a little bit. So 1/25 x squared, that's the only x squared term, so that gets to stay. Negative 1/35, so we have an xy term and an xy term, so negative 135 minus 135. So we're basically like a negative 1 minus 1, so this is going to be minus 2/35 xy plus 1/49 y squared. So remember, same denominator, so all we're doing is basically subtracting the numerator. So negative 1 minus 1, negative 2, denominators stay the same. This is, we're just subtracting fractions here. Okay, so we get that if we just run it through the distribution. So if we ran it through our formula, which is this guy down here, then we would have a is equal to 1/5 x, b is equal to, which is the second term, 1/7 y. We're running through the subtraction. Okay, a squared. Okay, so square a. 1/5 squared is 1/25. X squared is x squared. Okay, put a minus sign. Okay, a times b. Okay, 1/5 times 1/7 is 1/35. Double it, so that'd be 2/35. And then x times y. And b squared, okay, so take 1/7 and square it and put a plus sign. Okay, so put a plus sign, take this and square it. 1/7 squared is 1/49. Y squared is y squared. Okay, so whether, again, running it through the formula or multiplying it out, you're going to get the same answer. Alright, next example. Okay, what about a product of conjugates, right? One's a plus, one's a minus, but our a and b are exactly the same. So let's look at multiplying it out, what it looks like. Okay, so 5, I'm just going to recopy the problem. Plus 6 times 5k minus 6, okay. 5k times 5k, 25k squared. 5k times negative 6, which would be negative 30k. 6 times positive 5 would be plus 30k. And 6 times negative 6 is negative 36. Okay, look what happens here. We have a negative 30k and a positive 30k. Those guys cancel out. So we end up with 25k squared minus 36. Notice that's exactly 5k squared. Or sorry, that's exactly 5k squared. And 6 squared with a minus sign in the middle. That's where the formula comes from, is that the conjugates are going to blow each other out for this middle term. Okay, so if we use our formula, our a in this case would be 5k, or the first term, and the b would be, which is the second term, would be 6. Okay, according to the formula, I take the first term and square it. Okay, 5k squared, so square each piece. Okay, and then I put a minus sign in the middle. Okay, and then I take the b term and I square that. 36. There you go. A squared minus b squared. Alright, let's look at another one. And let's throw some fractions in here. So m plus 2/3 n, m minus 2/3 n. So let's do it as if we did not know that there was a formula way to do it. And m minus 2/3 n. Okay, m times m squared, m times negative 2/3 n, so that'd be n m, positive 2/3 n times m, so again we would get the mn, and m, and then positive 2/3 n times negative 2/3 n, so we get a minus 2/3 times 2/3, so 2 times 2 is 4, 3 times 3 is 9, n times n is n squared. So let's clean this up again. Notice minus 2/3 nm plus 2/3 nm, positive and negative of the same exact term, cancel each other out. So we would get m squared minus 4/9 n squared. Okay, let's do this again with our formula. A in this case is equal to the first term, which is m. B in this case is equal to the second term, which is 2/3. Sorry, 2/3 n. Okay. First thing we do, first term, square it. M squared. Oop, easy. N squared. Put a minus sign in the middle. Okay. Take the b term and square it. Okay, so 2/3 squared. We square the numerator, square the denominator. 2 squared, 3 squared. Okay, and then n needs a square also. And we're done. Still, m squared minus 4/9 squared. Again, a squared minus b squared. So I hope you guys liked the video. So this is, again, was the special products for binomials, whether taking the sum binomial and square it, or the difference binomial and square it, or taking the product of conjugates where you have a binomial, so they're basically the exact same binomial, but they're being separated by a plus minus. So as always, if you have questions, please just ask, and I really hope you enjoyed that video.